Hi, it's time for a M&S DMC1 repair video. And for those of you who have a Music and Sound DMC1 or its cousin model, the NuTone NM 200, this video might be interesting to you. And if you're curious as to why a DMC1 and a NuTone NM 200 are cousins, I'll put one of those pop-up tags right up here somewhere that'll take you to another video that explains the long story about how those two models became essentially the same. But on to the heart of the matter. So this DMC1 was sent in by a fellow named Marshall, and Marshall lives in Georgia. The information he gave me when he filled out our online repair request form is the system was installed around 2015. He thinks he's lived in the house for about a year. The information that he gave me was no stations work, only relay clicking can be heard. It was that way when he moved in a year ago. The master station display and logic seems to work. He's able to switch modes, display volume changes with button presses. Configuration menu is accessible. There is no audio from any station, including the master, from any source, which means no AM, no FM, no auxiliary, no CD in. The door chime doesn't work. Basically, it's a system that, for all intents and purposes, seems to operate correctly, but there's absolutely no audio from the system whatsoever. So we'll put his faceplate aside because we don't want it to get damaged. And here are the three primary circuit boards that make up a Music and Sound DMC1. We have the power supply amplifier board, we have the display / microcontroller board, and we have the main audio board. And those are it. There is a tuner board, a terminal board, some other miscellaneous stuff, but that's not really relevant to what we're working on right now. So the very first thing I did was to set up his Marshall system and hook it all up and verify what he explained, and he was correct. For all intents and purposes, it seems to work correctly. However, there is no audio of any kind whatsoever from any source or the chime module. The very first thing I did is what I usually do with a system like this is I did my usual intercom triage, which I've done other videos about, and I one by one substituted in a known good board that belongs to me for each of these other boards to quickly narrow down where the problem lied. So I took an amplifier power supply board that I know is good, that belongs to me, hooked it up to his other two boards, same thing, changed out the microprocessor board or microcontroller board, same problem, swapped out the main audio control board, and all of a sudden we had all sorts of audio and everything seemed to work correctly. Since we know it's not this, and we know it's not this, let's put these aside, keep them in safe keeping here because we don't want anything to happen to them, and talk about this, the audio control board. Now you might think, oh, well, that's good. We know which board it is and that should be simple to fix. However, that's not really necessarily the case. Why isn't that the case? This is the reason why that isn't the case. These are all audio control boards for the DMC1 or the NM200s. These boards span a period of time between roughly 2004 and 2016. So that's 12 years. So it's 12 years worth of production, which is a total of 6 boards. So the lifespan of each board and its design was approximately 2 years. This is what presents a huge challenge in trying to figure out and learn how to fix these models, because every 2 years the board was updated in some way or another, which makes it somewhat an entirely different board. Yes, there are aspects of each of these boards that are very similar to the other boards, but there are a lot of subtle or big changes that are introduced as time goes on, and that makes them very difficult. So to roughly give you a very brief overview of what we've got here, these are the earliest boards. Now, date codes on boards, sometimes these are date coded, sometimes these are not. So these are rough estimates for the ones that do not have actual date code labels on them. These are Rev D boards, and there are actually two of them here. If I put this one like this, So this is possibly the earliest Rev D board, D like dog, because I believe the date code on this is 2004, where I believe the date code on this one is 2007, but they're both Rev D of the same board. Even in that short amount of time, things changed on the board. You might notice this one has 3 relays, this one only has 2, and there would be more studying that goes on to determine that. They're obviously different boards because the board numbers are different. That's one of the subtle differences is. So on all of these boards, printed on the board, I'll show you, there's identifications here. Here we have a PCB board number, which is 501359 Rev B, but then we have the assembly number, which is 730359 Rev, and then they put a sticker that says D. So that board is a different PCB number than the other one. So they are different boards. Now that could be because there's a lot of changes to the layout of the board, or it could also be because the earlier one, maybe they changed where the boards were manufactured, a different board manufacturer, maybe a different country. This one doesn't have a lot of useful information other than what may be date codes on it. This one has date codes stamped on it, but also right here, it says made in Vietnam. So maybe they changed the production of the boards from wherever they had been being made to Vietnam. I don't really know because there isn't anyone to really ask. So these two boards, this one, the earliest one, I believe is 2004, and this one is 2007. Then we jump up to this board, and these are in chronological order as we go around here. This one is a Rev 01E, and this board is most likely from 2008. This board is a 01F1. See, the letters keep going up. And this board, I believe, is from 2009. Now, what do Rev codes mean? Well, Rev D obviously would be possibly the 4th revision of this board. The first board would be just the board number, and then you would have Rev A, B, C, and D. This one is Rev 01E, which I assume would be an E revision, and 01 is a minor. So when manufacturers usually use revision numbers on boards, you'll have a major revision, which would possibly be letters you go from D to E or E to F or F to G, but then there also may be a number associated with it as a minor revision. So this could be revision E, which was a major revision, and then it had a minor adjustment to it, so it's an 01E, where more typically you would see E.01, but I don't know why they did it the way they did it. So there's this one. This is an 01F1, which the F is obviously a larger revision and the 1 may be a small revision. There doesn't seem to be a lot of consistency in how they did this. That tells me maybe that the people at Music and Sound who were doing these revisions left it up to the manufacturing house to assign revisions, and that's the way their company did it, and it all seems rather hodgepodgey to me. Anyway, so the 01F1 board, this is from 2009. And then we jump up to an 01G revision, and I believe this one is from 2011. And then here, it changes dramatically. This is a revision 01HX, like X-ray 1. And this one, I believe, is from 2014. And then we have Marshall's board, which is a revision 01K, which would be the last one. And this is from, I'm going to say 2016, is date coded like the 50th week of 2015. So we're going to call it a 2016 board because that's probably when it was actually put into a unit. Now, you might be wondering at this point, how come he's got all these boards? Well, it's not just these boards, it's all of these boards, and it's all of these boards and more. And why do we have all these boards? Well, over the past several years, I've been collecting NuTone NM and Music and Sound DMC master stations. A lot of them are damaged and don't work correctly. Some of them actually work fine, but I've been collecting them because you cannot get boards from NuTone or from Music and Sound. They don't sell them, they don't have them available, they don't even want to talk to you about it. So it's on us to come up with a collection of boards because all of this is what you need to learn if you're going to be able to try to fix these. And so far, these have been a challenging thing to fix because there are so many different versions of it. One of the things I did recently, because I had this big giant pile of used and semi-used master stations, which take up a lot of room and it's kind of a pain in the neck, is I spent an entire day taking them all apart. And I sorted everything out. So audio control boards go in their bins, microcontroller boards, they go in their bin, amplifier power supplies go in their bin, tuner boards go in a bin, everything goes in a bin. I have a bin full of screws and connectors and cables and speaker cones and all that kind of stuff. So everything has been sorted out, and as each set was disassembled, I logged in all of the individual boards that came out of that set because it gets rather complicated. Power supply and amplifier boards like this, they have their own rev numbers also. This is an 01A, which is actually a fairly common one. And microcontroller display boards also have rev numbers. This is an 01N, and this actually changes. These change a lot over time, just like all of these do. These would be, I don't have the book in front of me, but this board would belong to one of these boards, and it makes a set. You can't necessarily take this board and use it with this one because it's not from the right time period. They have to be from the same time period. So as I disassembled all the sets, I logged in the different boards that came out of each set so I can eventually build a chart as to which combinations work with other boards. So on these boards, when you go from here, which is roughly 2004, all the way up to this one, which is approximately 2011, well, there are changes to each of these boards. They're not, as near as I can tell, without like fully reverse engineering each and every board, which takes a lot of time, and I don't have time for that often. There are a lot of changes to the boards, but the changes seem to be more minor than major. So why do companies change boards? They change designs of boards because they find an error in the board and they want to solve it. They change the design of a board because components change over time. Maybe this component, I'll show you this one. So this one and this one are actually the same integrated circuit. They're both made by Sanyo. They both have basically the same part number, but this one is a larger package than this one. So it may be that Sanyo was discontinuing this larger package in favor of this smaller one. I know these were available probably mostly at the same time, but maybe this one had end of life. End of life is when a manufacturer says, hey, we're going to discontinue this large package one, and if you need a lot of them, you better buy them now because in a year or 18 months, we're not going to have any more. That's a time a manufacturer would redesign the board to accommodate this smaller part. That's a small change, although you have to have the right size package to put on the board because this part continues on all the way until here. That's one of the reasons why manufacturers change the design of a board. Also, like most companies, when you're making consumer electronics, which is what this is, you change things because it saves you money. You find a way to do it for less. Maybe you can eliminate some parts. Maybe you can streamline the manufacturing. Maybe you can do a lot of things. And if you only save a few cents per board, but you're making 100,000 boards, it adds up over time. So let's do something. Let's take these two and this one and put them aside. We're going to put Marshall's board up here, and we're going to move this one and this one right here. All right, so we're looking at our two example boards. Marshall's board is still up there. This is the 01G board, which is from around 2011, and this is the 01HX, like X-ray 1 board, which is from approximately 2014. And if you look really carefully, you might be able to spot some big differences, but I'm going to point it out to you because that's what I do. So this board is like all of the previous boards, for the most part, that were made for this model. The differences between this board and this board have all to do with this and with this. This chip right here is the Sanyo chip, and I cheated because I printed out the data sheet for all of these because it becomes rather complicated and I don't want to say things incorrectly. So this little chip right here, which is an LC7537, is the Sanyo part number, is basically an electronic volume control system for audio equipment. Sound familiar? And the brief explanation of it is, it's an electronic control capable of electronically controlling the volume, balance, loudness, fader, bass, treble functions individually with fewer external components. So this is basically all of your audio control. Now, those of you who have a NuTone NM system or a DMC system know that if you use the tone button on your master station, it opens up a set of menus and it allows you to adjust things like the master speaker volume, the loudness on and off, the bass, treble, intercom, and music level throughout the system. And all of those things are done inside this chip right here. And this chip in this version is different than this chip in this version, and also all of these components here in this area don't exist on this board. Why is that? So this one in the 2014 version, this is a chip that was made by Princeton Technology Corporation, who I have no idea who they are. The description for this chip, this is a PT2313E is the chip number. It says, this is an audio processor designed for versatile application, includes 3 stereo input selector with adjustable gain, master volume control with low frequency loudness compensation, individual output attenuation, tone control. It's a good solution for car audio signaling processing, and the applications are car audio, home audio system, powered speaker system. Sound familiar? It's an intercom system. It can be used in audio equipment and primarily in moderately priced consumer electronic-y kind of stuff. What makes this chip work is this chip over here. And you might notice this one, if you look really, really carefully, it has a little white label on it. And the reason it has a little white label on it, the white label says BF7B, don't know what that means, and then it says V as in version 1.0. And so what is this little chip? Well, I found out because on Marshall's board, right here, I peeled the sticker off and cleaned off the goo to see what it said underneath. And this is a microchip PIC16 8-bit microcontroller. And a microcontroller is like a microprocessor, only way less powerful. Microcontrollers are used in all kinds of consumer electronics, and the purpose of this chip is this chip controls this chip. Because this chip requires a microcontroller or a microprocessor to control all of those features that it has built into it. And in Marshall's case, on his board, this is the little white sticker right here that I peeled off of it. This has the same lettering on it, except this is a version 1.1, which tells me that the firmware are the instructions that are loaded into the microchip. The instructions that are in this one are somewhat different than the instructions that are in this one because there's a revision number. Now, as for this chip, the Princeton Technology Corporation part, I printed out the data sheet for that. It's about 5 pages long. Most of it's very boring. But if you look here, this is for those of you who may or may not know how to do this. If you look here, here's the chip. Here's all the pinouts on it, and it shows how different parts of a circuit would be connected into it and out of it to make it do or let it do what it can do. And if you look very carefully and you go through all of this here and all of this here and you compare this to this section of this board, they're virtually identical. Not 100%, but pretty close, because what happens is when engineers are designing something like this board and they're going to use this chip right here, they're not going to figure all this out on their own. They're going to go to the chip manufacturer's data sheet, and they're going to look what the chip manufacturer recommends, and it's like, oh, that's what we're going to do because it's easy, because I don't want to work that hard. Let's be lazy and we'll just copy what they gave us because the manufacturer says that it'll work. And that's how things are designed nowadays. So this chip is interesting because it controls all of the audio in and out audio, whereas this one does not control the in and out audio. This one has all of those other features like volume, bass, treble, balance, all those sort of things. This one has that also, but this doesn't control the audio input or the output. That's done somewhere else. And where is that done? Well, my guess is, although I don't know for a fact yet because I haven't worked on it long enough, is that this is all controlled by the microcontroller that's on the display board, and its firmware that's inside of it. Now at this point you might be thinking this is getting rather geeky and it's all sounds somewhat interesting, but why do I care? Well, maybe you don't care, but you might care later on if you have a problem with your NM or DMC intercom, because, well, this is a fairly standard analog audio type board, where this one is not, because this has a digital aspect because it has a microcontroller. In the case of Marshall's board, let's put his board here for a second. Here's his board. The question is going to be, where does the problem lie? Well, the problem could be with this chip, or the problem could be with the microcontroller chip. At this point, I'm not sure, because all of the signals get fed into this one and then out of this one, but the feeding in and out are controlled by this. Where this becomes complicated is I have to probe this board to, one, make sure the signals are going in, which I'm pretty sure they probably are. And then you can also probe on the output side to see if any signals are coming out, which I'm guessing they're not. But then the question is this chip bad? Or is this chip bad? Is this one bad because it's not working the way it's supposed to? Or is it not working the way it's supposed to because this one isn't telling it what to do? Now this chip is probably still controlled to some degree by the main microcontroller on the display board. But I don't think it's a problem with that one, because the other information that comes out of that microcontroller, which shows up on the display, seems to work correctly and it tunes correctly and so forth. So I don't think that's the case. And also we substituted that board with a known good board and the problem still existed with Marshall said. So I don't think that's the case. So now we're back to the part about why do I care about this? Why do you, the watcher, the viewer of this video, why do you care about this? Well, you'll care about this if you have one of these later models with an extra microcontroller on it and this chip, because if it happened to this one, it could happen to other ones also. The only way to really determine what's going on here is to probably do some probing to make sure signals are getting to this chip. And if nothing's coming out of it, then the only practical way to try to troubleshoot it is to replace this one with a same exact chip, which we have some, and see if that solves a problem or not. If it's a problem here with the microcontroller, then this board becomes unrepairable. Not because this PIC16 part is not available, because it is, and it costs a few cents. They're not expensive at all. I might spend maybe 45 or 50 cents for one, and I certainly can install it onto the board. That's not a problem either. However, it has to be programmed with the correct firmware to make it work in a DMC1 master station, and there is no way to do that. There is actually a header here. I believe this is the programming header. So when this board was manufactured, all these parts would have been soldered onto the board, and at some point in the manufacturing process, it would have gone into a jig of some kind where there were pins that pressed down on these little round pads, and it would be hooked to a computer, and the computer would upload the firmware into the PIC16 so it would work in a DMC1. A PIC16 is not a chip that was made just for music and sound DMC1 master stations. They're used in all kinds of consumer products, and they can be programmed with all kinds of firmware to do all kinds of things. PIC16 is actually a fairly common chip. You might have one in your programmable thermostat at home, but it has firmware in it that makes it work with your heating and cooling system, not with a DMC1 master station. And that's where you get into the problem. The problem is that if this is bad or the firmware is corrupted, then this board is toast. There's nothing you can do with it. There is no practical way to fix it, and there isn't any sense in removing one of these microcontrollers from another board like this and putting it on Marshall's board, because why would you do all of that work if you have a complete board that works with the working chip on it? You could just swap out the boards. And that's the problem you get into with more modern consumer electronics. Boards that have microcontrollers and have firmware can become unrepairable. That's just the nature of the design. And just as an aside, to explain to you, maybe so you get a better feel for it, how versatile and complicated a little chip like this is the first page of the data sheet for the PIC16 right here. And I only printed out the first page because the entire data sheet packet is 298 pages long. And that would be what you would print out if you were a design engineer or a firmware, an embedded firmware engineer, and you were working on a board with a part like that. You would need those 298 pages to learn all about how this works, how you deal with it, how it gets used in a product that you're designing. So there you have it. I have nothing else to say about this other than this is just dog dirty hard to work on. It's really, really difficult. You know, I did do a video a few years ago where someone sent me a set of schematics for DMC master stations. However, those schematics are, I believe, early production or pre-production schematics, and they don't bear any resemblance to this at all. The whole extra microcontroller thing with this chip over here changes the whole scenario quite a bit and makes it extra difficult. So I don't know if this will be helpful to anybody. In some respects, this type of video is helpful to me because talking through it helps put the pieces in their proper places and lets me look at things differently sometimes so I can figure out how to fix Marshall's intercom, or at least how to figure out the methodology used to troubleshoot the intercom. While this board, if it does have a problem with this, may become unrepairable, part of what you have to do is you have to figure out and develop test and measure procedures to determine if that's actually the problem or not. That's no small feat. That's a difficult thing to do, especially when you don't have true schematics for it, and the amount of time it takes to sit down and draw out this, reverse engineer it, is very time consuming to do. It could take days and days and days to do that, and at this point, not going to do that. Maybe sometime in the future, but even then, it's unlikely. I hope you found this interesting, and maybe for someone it will be helpful. If it is, give it a thumbs up on YouTube because that helps us just a little bit. There'll be a banner right here that shows you how to subscribe. Go to our YouTube homepage, click on the bell, and when you click on the bell, click on it to receive all notifications, and every time we post a new video, you'll get a notification and you can watch it. That's all for today. See you on the next video.